Welcome in to a special interview from the Association for Materials Protection and Performance. My name is Ben Dubose, and I'm a staff writer with the AMPP Publications team. Today, we're joined by Dr. Mehrooz Zamanzadeh, best known as Dr. Z. Dr. Z is currently a technical director and principal investigator on projects related to buildings and the utility industry at Pittsburgh, Pennsylvania-based Matergenics. He is a fellow of NACE and ASM and certified by NACE in corrosion, coatings, cathodic protection, and materials selection and design. He brings nearly 30 years of practical experience in those fields. With him, we also have Nathan Pace, Corrosion Engineer with Matergenix. Dr. Z, Nathan, good afternoon. How are you?
Hello, we are doing fine.
Doing well.
So the reason we have you on today for this interview, Matergenix recently issued a preliminary report on the deadly collapse of the Champlain Towers Condominium complex near Miami. And that report includes plenty of information regarding the potential causes and specifically the potential role of various factors related to corrosion. Dr. Z and his team are currently drafting a technical paper on the topic, which is set to include all sorts of recommended practices for the corrosion risk assessment of aging buildings. Anyway, I think a good place to start, Dr. Z, is with your recent visit to the site of the Champlain Towers collapse to do some consulting. Can you tell us a bit about what you saw there in terms of the potential corrosion-related issues that may have caused this tragic incident?
Well, first let me tell you that my heart goes out for the hundreds of families that feel pain of losing their loved ones. This should never happen again, in our opinion. I did visit Miami at the time. They did not let the experts to get close to the site because of the safety issues. However, we did review extensive amount of information, including the drawings, all the photos, videos, and all that. And we have been involved in this similar type of high-rises, aging structures for some years. So we know what's going on in this type of environments, especially if the structure is aging and is in front of the ocean.
So what red flags did you all see when looking at some of the inspection reports prior to the collapse?
Well, basically, corrosion risk assessment should include corrosion mapping, GIS corrosion mapping, building corrosion mapping, should include quantification of corrosion, should include loss in thickness, should include recommendations, specific recommendations, and if the risk is acceptable or if it's not acceptable. The previous inspection reports were inadequate as such that they were not detailed and they did not quantify the corrosion risk.
So what advice would you give to any other building owners that may have received or may be receiving similar information on their own inspection reports?
Well, first of all, I would like to tell this very important issue that the 40-year recertification is not adequate. Obviously, this building failed before the 40-year recertification. Recertification and inspection frequency should be based on previous inspections and also corrosion risk assessment. The code in construction and inspection in Miami-Dade and other areas should include corrosion risk assessment and corrosion mitigation in order to prevent this type of structural failures. Generally speaking, buildings fail due to two main reasons. One is corrosion, the other one is fatigue. Corrosion is a time issue. It means that when the load-bearing members are exposed to corrosive environments, they start losing their thickness, their load-bearing ability, and as such, they are prone to incidents or accidents, a major accident that sometimes are deadly, and hundreds may die due to that accident. So my advice to neighboring buildings, my advice to aging buildings in Miami next to the ocean, in Honolulu, in San Francisco, in Vancouver, Canada, is to consider corrosion risk assessment of their aging structures.
So turning things back to the Champlain Towers and that tragedy in South Florida, again, I know you were just on the ground there. Can you describe some of the factors, or perhaps the red flags is the right way to phrase it, but can you describe some of the things that you saw that might have indicated or contributed to the corrosion risk in that environment?
Well, basically, when you are next to the ocean, 100, 200 feet, it's called C5 environment. Those are marine environment. It means you have high chloride deposition, you have high time of wetness, and therefore corrosion risk is present in this type of buildings, especially if they are aging, So that's the first consideration. For aging structures, past is not indication of future if they are in a corrosive environment and they are next to the ocean. The second aspect of it is, from our observations, more likely than not, the collapse started in the lower floors. And it started from an area that was pool deck and the parking garage area. Mm-hmm. We think what happened is this accident, unfortunate accident, didn't happen overnight. It was in making for decades. There was evidence, a strong evidence of collection of water on pool deck, extreme amount of water flooding in the parking garage area. And as such, this water can evaporate. When it evaporates, it concentrates the salt. Mm-hmm. The water and the salt water can permeate through this concrete. It can get to the rebar and form a corrosion cell. Corrosion products, or what is called rust, forms. That results in cracking of concrete and further accelerated corrosion. What's the result of all these reactions? Loss in thickness of the rebar. Once you lose the thickness of the rebar, then your load-bearing ability is not the same. My colleague here, Nathan, is going to show you an example of what we have seen in past.
So this is a core sample from a 100-year-old building that we've done an inspection on before. And you can see there's rebar inside of this concrete core sample. And if you look very carefully, you can see that it is flattened out and it's lost nearly 50% of its cross-sectional thickness. So this is just one example of what can happen with rebar. Another thing that can occur with rebar inside of concrete is that whenever you produce, whenever the rebar begins to corrode, you produce an oxide, and that oxide can expand and cause sections of the concrete to completely delaminate and come off. You can see a line here that is staining from the corroded rebar, but this was part of a wall that completely delaminated and is weakening the structure by doing so.
There's been a lot written in the media about spalling in some of these reports. Dr. Z, can you just give a brief description of that for any non-corrosion folks that might be watching or listening to us? What does that mean when the media uses that term?
Well, spalling is very common in corrosive environments, such as marine environments. And the reason for it is, as I mentioned, the salt water can go diffuse through the concrete, get to the rebar, form a corrosion cell. This corrosion cell can cause acceleration of the corrosion process and formation of corrosion products. That results in cracking and separation of section of concrete. It's called spalling. And whenever you see that type of thing, obviously, that's an important issue. I do like to mention 1996, only 15 years after the installation of this large building, they started to see the evidence of spalling, and they did repairs for 500 feet of the slab at the time. That just tells me there was something cooking at the time. There was something cooking. What could go wrong? Well, we said salt water can permeate through the concrete, get to the rebar. So the cover concrete is very important. If you have, let's say, 1 inch, 1.5 inch, or higher, the higher it is, it takes longer time period for that salt water to get to the rebar. So basically, that's an important issue in marine environment. For this building, when we looked at the drawings, it did not have adequate cover. It did not have adequate drainage in the pool deck. It did not have adequate areas that waterproofing has been installed. Waterproofing in this type of building next to the ocean is an important, it acts as a barrier for salt water to get to the rebar. So basically what you see here is inadequate barrier for prevention of salt water to get to the rebar, inadequate drainage, inadequate design for concrete cover. All this is telling me the corrosion is more likely than not accelerated, either contributed extensively or even the primary cause of this disaster.
Great insight there from Dr. Mehrooz Zamanzadeh. Again, he's best known as Dr. Z. To his left, we have Nathan Pace, Corrosion Engineer. Both of those guys are with Matergenix. And I want to stress, again, my name is Ben Dubose. I'm a staff writer with AMP. We know the official cause has not yet been determined. Investigations are ongoing. We're simply speaking as an association that represents the corrosion industry about some of the reports that are well established in the media, the potential role of corrosion in this tragedy. And I suppose to spin it forward, Dr. Z, what do you see as the main challenge in determining the official cause of the Champlain Towers collapse? Where do things go from here, and what are going to be some of the challenges for the folks on the ground in determining an official cause?
Well, the official cause should be a team effort, in our opinion. In past inspection, in past construction codes, did include the structural engineers, rightfully so. However, they did not include the corrosion, NACE certified corrosion engineers, AMP certified corrosion engineers. The biggest challenge is for this work to go ahead and find the root cause is to find the right team members with experience. And once you have that, then you go after where the whole failure initiated. Is it due to design? Is it due to workmanship? Is it due to environment, corrosivity of the environment? Or is it the combination of those? Once you have the primary cause, then you need to do the solution engineering. Now, the answer is not always to replace the slab or any major components. Corrosion engineers are aware. Corrosion engineers know new technologies that can be used with low amount of fraction of the cost of replacement if the corrosion is captured on right time, like e-injection, electron cathodic protection. Once you do that type of thing, you don't need to spend $14 million. You can spend fraction of that and repair the structure and have high confidence level that the structure is going to last long time. That's the next important issue. So in my opinion, in summary, the condition assessment should include corrosion engineers, looking at the structure from corrosion engineering point of view and considering that in solution engineering of the problem.
So let's talk about the country as a whole, because I think a lot of the response to this obviously what's going on in South Florida is a tragedy, but you also have so many building and asset owners all around the United States, really all around the world, but we'll stick with the US for purposes of this interview. You have these building and asset owners that want to make sure that this doesn't happen to them, and they want to know what they can do to improve their odds of avoiding such a tragedy or even a fraction of the devastation what's going on near Miami. So let's talk about the US as a whole. The 40-year recertification cycle, is that practiced nationally or is that on a state-by-state basis?
I believe it's a state-by-state basis. And however, this type of recertification is not considering the corrosivity of the environment, which may be determining factor for incidents or accidents.
When we're talking state by state, are there any specific states that are getting it right? Are there some that are even more than 40 years? Just curious on a state-by-state basis where things fall on that scale.
Not that I know. There are many codes, many local codes that they are up there. I know there are some differences from one state to another. However, in general, the corrosion engineering concepts are not considered in frequency of inspection.
So what would you recommend as a more appropriate cycle? Basically, what can and should be done about buildings or buildings in those states where you have 40 years or more for recertification efforts right now?
Excellent point. Excellent question. 2/3 of high rises in Miami are more than 30 years old. 2/3 of them. What I recommend is the following. A corrosion risk assessment, GIS corrosion mapping should be performed first, based on the environment, how corrosive it is, time of wetness, salt deposition, determine the frequency of inspection and recertification. It may be 20 years, it may be 30 years, depending on a specific environment and the results of corrosion risk assessment.
So we've spent a lot of this interview talking about why coastal buildings and these types of highly corrosive environments can be more at risk of concrete corrosion. Are there other areas, environments, or circumstances, I suppose, where people really need to be more vigilant when it comes to preventing concrete corrosion?
Well, in Northeast, we know it is a common practice to use de-icing salts. De-icing salts. And the time of wetness is very high. There are many, many aging buildings that are exposed to, like bridges, like towers, like poles, that are exposed to de-icing salts and what we call corrosive moisture that contains that de-icing salts. All these areas should be of concern. They should be on their toes for this issue, especially if they are aging. You can drive through Chicago, you can drive through New York City, you can go to Pittsburgh, Pennsylvania, and see the same phenomena, same mechanism is in action.
So at Matergenix, do you all work directly with the building inspectors, the structural engineers, when you're trying to identify these types of corrosion-related issues and look into what the repairs are? What's your role? Are you working directly with these people in some cases?
That's a true statement, yes. We do the corrosion risk assessment at some area. And we identify the areas that exhibit accelerated corrosion due to the corrosivity of the environment and time in service. Then we do the digs. We identify the load-bearing members. We measure the thickness loss. And then we work with FEA analysts, structural engineers to see what's the effect of this loss in thickness. And we determine, based on all these issues that I mentioned, the remaining life and what should be done next, which is usually coating and cathodic protection after initial repairs.
For anyone watching or listening that's thinking about conducting an inspection or getting an inspection done for their own building, how important is it to specifically get a corrosion engineer to be involved in your inspection?
It is important if you see early signs of corrosion. What are those? Red discoloration, formation of rust, formation of black rust, magnetite, is an indication that accelerated corrosion may be happening. Once you see evidence of this type of things, then you know that there is some corrosion mechanism active in your structure. You should get the advice of a NACE certified corrosion engineer that has worked before with this type of environments, and ask them to do the condition assessment with structural engineers. This should be a teamwork.
The last question I've got for you, from our perspective at AMP, what role do you see for AMP and specifically its members all around the world when it comes to investigating and preventing future tragedies like what we've been dealing with in South Florida? And when I ask this question, I'm not just saying for residential structures only, but really any sector where corrosion failures could have catastrophic, potentially fatal results. What can AMP and its members do?
Generally speaking, failures come through three main reasons. The first one is lack of knowledge. They just don't have any knowledge about the mechanism. The second one is very important, that should never happen, but it happens, is negligence. Negligence. And sometimes greed plays a role in the whole subject. If it's very expensive, then they may not pay as much attention. In my opinion, what AMP can do is to increase the knowledge of corrosion risk assessment of aging structures in general, the infrastructure we have in this society, and have specific courses, as I know they do, regarding this issue, so we can eliminate the first aspect, which was lack of knowledge. The negligence comes even very seriously, teaching, educating the technicians, the engineers regarding what can go wrong if detailed observations are not in place.
Great insight. Dr. Z, we mentioned leading off this interview the reports that you have that are ongoing regarding the Champlain Towers and, of course, the aftermath of your visit on the ground in South Florida. For anyone watching or listening that wants to keep up with you in the weeks and months ahead and the insight that you put out related to what's happened, how can they do that? Are you on LinkedIn? What's your website? How can people stay in touch with you or follow what you're going to be publishing as it pertains to the Champlain Towers?
Well, no need to say that this is work in progress. That's the first thing that we should pay attention. But we do have a white paper regarding corrosion risk assessment, corrosion mitigation of aging structures. It's available. If anybody is interested, they can get in contact with Matergenix, zee@matergenix.com. And we are listed in LinkedIn. And also we have had many interviews with media, including Wall Street Journal and others, that we have presented our technical views on this tragic accident. And we also believe this should never happen again.
Yeah, I think that's a good point to end on. And as you mentioned, you've been doing a lot of interviews, really doing great work to provide the corrosion perspective on this tragedy and what can be done to prevent future ones. And for anyone that has not seen those interviews, you can also check out YouTube. You can search for Dr. Z and see all sorts of interviews that he's done in recent weeks, trying to get the word out about what's going on in South Florida and what building and asset owners can do to prevent it from potentially happening anywhere else. Also, if you want more information on their company, Matergenix, it's pretty simple, matergenix.com, and you can find all sorts of ways to get in touch with them.